Welcome to this explainer. Today, we are opening up the doors to the diagnostic clinic. We're going to examine the common symptoms of failing math answers, specifically looking at the notoriously tricky topic of integration. And we are going to prescribe the exact cures you need to completely ace your Cambridge IGCSE Additional Mathematics exams. If you've ever felt like your math grades are just randomly bleeding marks for absolutely no obvious reason, well, you are in the exact right place. We're going to treat every single problem we encounter today exactly like a lead physician treats a patient, methodically, accurately, and with a crystal clear strategy. Let's get started.
Look, learning calculus can absolutely come with some serious growing pains. We've all been there. But this brilliant quote from N.R. Narayana Murthy perfectly captures why we have to push through that initial struggle. It's completely understandable to feel a bit uncomfortable when you first try to wrap your head around integrals. It's a whole new way of thinking. But honestly, staying stuck, feeling frustrated, and settling for lower grades when you know you can do better, that is way more painful. So we're going to push through that pain together today with clear, logical, step-by-step solutions.
Here is our patient roster for today. We'll start with the basics, move on to diagnosing indefinite integrals, tackle definite integrals, solve the mystery of areas under the axis, look at some advanced functions, and wrap it all up with a real past paper case study.
Let's dive right into Section 1. Welcome to the clinic. Here we're defining our foundational cure.
Before we can fix anything, we need a baseline understanding of what integration actually is, right? Think of it this way. If differentiation is taking something apart to find the precise rate of change, like looking down at your car's speedometer at 1 exact second on the highway, integration is putting all that data back together to find the total value. For instance, imagine a runner wearing a high-tech speed meter. By taking all those hundreds of individual split-second rates of speed over time, integration literally allows us to calculate the total distance she ran. It is the mathematical reverse of differentiation. It's putting the puzzle pieces back together.
For any standard algebraic term, this simple three-step procedure is your absolute primary prescription. Seriously, burn this into your memory. If you have x to the power of n, you simply add 1 to the power, then you divide the whole expression by that brand new power, and finally, and this is absolutely crucial, you add an arbitrary constant which we call c. So x squared becomes x cubed divided by 3 plus c. It's that straightforward. Now, the key thing to remember here is that this works perfectly as long as your initial power is not -1. If it's -1, this rule completely breaks down because you'd be dividing by 0, which is a mathematical disaster. We'll treat that specific symptom a bit later in our advanced clinic. Before we continue diagnosing indefinite integrals, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Okay, moving right along to Section 2, diagnosing indefinite integrals, where we'll be locating that pesky missing constant.
This is the absolute most common place students needlessly bleed exam marks. They do all the hard work, integrate the expression, and then just forget the constant. But what does that constant actually mean? Well, when you integrate and just write plus c, that's what we call a general solution. Because c could be literally anything. It could be +10, -50, or 0. It actually represents a whole infinite family of parallel curves hovering up and down the y-axis. It's an unfinished diagnosis. But if the exam gives you a specific coordinate point that the curve passes through, let's say the coordinate's 1, 4, you can finally solve for c. You just substitute 1 for x and 4 for y into your equation. Suddenly, the mystery is solved. In this specific case, c turns out to be exactly 3. You've now found the particular solution, which zeroes in on one specific exact curve, y equals x cubed plus 3.
That brings us to Section 3, the definite integral cure, setting the boundaries.
So, what if your examiner wants an exact numerical value instead of just an algebraic equation? That's when we prescribe the definite integral. What's really fascinating here is the transformation from pure algebra to pure arithmetic. A definite integral comes with two set boundaries, an upper limit and a lower limit. You'll see these written as little numbers at the top and bottom of the swooping integral symbol. You go ahead and perform your standard integration, but then, instead of stopping, you substitute your upper limit into the x values, and then you subtract the result of substituting your lower limit into the x values. And notice what happens to our friend c during the subtraction. Since you have a plus c in the first bracket and a minus c in the second bracket, it completely cancels itself out. No c required. The definite integral acts like a highly precise surgical procedure that leaves you with a final, solid, concrete number.
Let's move straight into Section 4, area under the axis, the negative anomaly.
This section contains a massive diagnostic trap that catches thousands of students off guard every single year. You were in the exam hall, you're calculating the shaded area enclosed between a curve and the x-axis, but what if that physical region dips completely below the horizontal x-axis line? It's a vital question to ask yourself, because the pure mathematical outcome of this specific integral might actually shock you. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGC to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to at acetheexams_IGC and turn on all notifications so you never miss our weekly exam strategy sessions.
All right, let's reveal the answer. Integration yields a negative result for any area mathematically located below the x-axis. Think about how dangerous that is for your grade. If you have a wave-like curve, say it goes above the axis for a while and then dips down below the axis, and you just blindly integrate across the entire thing in one go, the positive area on top and the negative area on the bottom are going to subtract from one another. In some extreme cases, like a curve with perfect rotational symmetry around the origin, they will perfectly cancel each other out, leaving you with a mathematically calculated area of 0. And obviously, a physical shape doesn't have an area of 0. So what's the cure? Always draw a quick sketch of the graph first. If you see a section dipping below that axis, you have to calculate that specific definite integral separately, take the absolute positive value of it, and then add it to your total.
Welcome to Section 5, Advanced Function Treatments. This is our clinical prescription pad.
Sometimes basic algebra just isn't what's making the patient sick. We might be dealing with complex trigonometrics or wild exponentials. That's when we open up the Advanced Medical Toolkit. Remember earlier when I warned you that you cannot use the basic power rule for x to the power of -1? Well, here is the cure. Integrating 1 over x is a unique, highly specific exception. It yields the natural logarithm of x, or ln absolute value of x. Meanwhile, e to the power of x is delightfully simple to treat. It just stubbornly stays as e to the power of x. For our trig functions, you've got to memorize these. Sine integrates to negative cosine, and secant squared integrates to tangent. Oh, and one absolutely vital red alert reminder from the clinic. Whenever you are integrating trigonometric functions and plugging in those definite limits, your calculator absolutely 100% must be set to radians, not degrees. If you're in degrees, you will lose the marks.
Finally, we've arrived at Section 6, Past Paper Case Study. Let's pass this final exam.
It is time to put our entire diagnostic system to the ultimate test, using a genuinely complex scenario pulled directly from the Cambridge 0606 syllabus. When you open your exam paper and you are presented with an area trapped between two completely different functions, do not panic. Panic is the wrong response. We're going to perform a very methodical operation here. We want to find the exact area sandwiched perfectly between the straight line y equals x plus 1 on the top and the quadratic curve sweeping right underneath it.
By meticulously following these 4 clinical steps, we guarantee a perfect outcome. Step 1. We have to figure out where these lines actually meet. We set the 2 equations equal to each other, and our mathematical diagnosis shows they cross at x equals 0 and x equals 3. Boom! Those are now our definite integral boundaries. Step 2. Set those limits. Now, Step 3 is the real genius move. Instead of doing 2 massive, separate, easily mess-upable integrations, we subtract the bottom curve's equation from the top line's equation right away. We do the algebra first. Combining them leaves us with a wonderfully simple expression, 3x minus x squared. Step 4. We integrate that combined equation, plug in our definite upper limit of 3 and our lower limit of 0, and evaluate.
And look at that. The final mathematical cure comes out to exactly 4.5 square units. No missing constants, no negative access traps, just pure, accurate math. By trusting the process, combining the equations first to save time, and remembering exactly how definite boundaries work, we have successfully extracted full marks from what looked like a really intimidating past paper question.
Take these strategies with you into your next study session. Sketch those graphs before you calculate an area. Always remember your plus c constants on indefinite integrals, and know your special trig and exponential functions inside out. Mathematics, honestly, does not have to be a stressful guessing game. It is a highly structured, totally solvable system. So I leave you with this final thought. Will you treat your next exam as a series of impossible hurdles, or is it clinical diagnosis, just waiting for your precise mathematical cure? Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos.
Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCS and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.